Alright guys, so I created a video here. I've taken a screenshot of the four questions on the stoichiometry practice quiz. Obviously, you know, these are kind of scattered, so you should have similar questions to these that you should be able to match up with the questions you received. I just want to go through each of the four questions so that you guys can review and kind of see how the work should be set up and how to reach each answer. So question 1, you have the given reaction of 5A plus 2B results in a product of 2C. Molar masses for A, B, and C are provided. And it says calculate the mass of C that can be produced from 12.62 grams of A. So in this stoichiometry problem, I'm going to be going from grams of A, and I need to get to grams of C for my final answer. So I need to figure out what I need to do in between here to get from grams of A to grams of C. And to do that, I'm going to have to go to moles of A first, then I can go to moles of C, and then I'll be able to get to grams of C from there. So we need to set up our whole entire stoichiometry sequence down here. So I'm going to start with my starting value of 12.62 grams of A. My first step is to get to moles of A, canceling grams of A. So I'm going to show my unit cancellation throughout. I have grams on the top here, grams on the bottom there of the same substance, so I'm able to cancel that. Step 2 is to get to moles of C, canceling moles of A from the previous step. So again, moles of A on top, moles of A on bottom, so I can get rid of it. And then the final step, I'll have to zoom in a little bit since I'm running out of room. I can get to grams of C by canceling moles of C on the bottom. And then I can do my final unit cancellation, moles of C on top, moles of C on bottom, and I end up with grams of C at the very end for my final answer. Now to fill everything in, my first step, going from grams of A to moles of A, I'm going to use the molar mass of A provided. So I'm going to be using this number here. That means that 1 mole of substance A has 12.78 grams. On the second part of the question, you need to get from moles of A to moles of C. To do that, we're going to be using the coefficients from the balanced equation. So I have a 5 coefficient in front of A and a 2 coefficient in front of C. So I have 2 over 5 for the mole ratio. And then the final step to get to grams of C, you're going to use the molar mass of C provided. That means that 1 mole of C is 30.48 grams. Then you can plug all of that into your calculator, and I will try to verbalize that for you. I'm going to be plugging in 12.62 divided by the 12.78. Then I'm going to multiply by, in parentheses, 2 over 5 for my mole ratio. And then the last step, to multiply by the 30.48 grams, and my final answer will be 12.04 if I round, and that's grams of C. So that's how we would do a gram to mole to mole to gram stoichiometry question. We were provided grams of one substance, and we can convert to moles of another substance. We went from substance A to substance C. The second question we have the given reaction, 6A plus 3B gives you 2C. Molar masses for A, B, and C provided. It says calculate the mass of C that can be produced from 17.1 moles of A. So this question is really similar to question 1, except for instead of starting with grams of A, we've started with moles. So we've really eliminated a step here in this question. So we're going to be going from moles of A to moles of C to grams of C. I'm going to start down here for my work. I'm starting with 17.1 moles of A. My first step is to get to moles of C, so I'm going to put it on top, and I'm going to try to cancel moles of A by putting it on bottom. And so again, moles of A on top, moles of A on bottom, it goes away. The second step is to get to grams of C, canceling moles of C, unit cancellation, moles of C on top, moles of C on bottom. I end up at grams of C for my final answer. To plug everything in, we need the mole-to-mole ratio to go here, using the coefficients on the balanced equation. In the balanced equation for C, there is a 2 coefficient, circling that there. And for A, there is a 6 coefficient, which again you see here. And then the final step to get to grams of C, I need to plug in the molar mass provided here. 35.78 for every 1 mole. Again, these are all for 1 mole of the substance. The only time you use the ratio is when you have moles over moles. So for my final answer, I'm going to be plugging in 17.1 times, in parentheses, 2 over 6, and then times the 35.78 for a final answer, 203.946 grams of C. And that is a mole to gram conversion. And this will be important, especially when we get to practicing the ideal gas law questions again. Question number 3. We have the given reaction 6A plus 1B gives you 1C. Molar masses of A, B, and C provided. Calculate the quantity in moles of C that can be produced from 13.67 grams of A. So on this question, we have started with grams of A. We're going to go to moles of A first, and then to moles of C for our final answer. So we're going to start by writing our starting value. We have 13.67 grams of A. We need to get to moles of A first, canceling grams of A as our starting value. Grams on top, grams of A on bottom, it goes away. And then our final step, we can get to moles of C, canceling moles of A. Moles of A on top, moles of A on bottom. Final answer will be in moles of C, which is what we want. To plug everything in, for our grams to A to moles of A, we need the molar mass provided for A. 1 mole of that substance is 19.42 grams. And for the final step, we need the coefficients in the balanced equation for both A and C. C has a 1 coefficient, A has a 6 coefficient. For our final answer, we will do 13.67 divided by the 19.42, multiplied by, in parentheses, the 1 over 6 mole ratio. Final answer will be 0.117 moles of C. And here we did grams to moles to moles. And the final question, the given reaction 6A plus 2B gives you 3C. Molar masses for A, B, and C provided. Calculate the quantity in moles of C that would be produced from 11.2 moles of A. So we're just doing a simple mole to mole conversion here, moles of A to moles of C. Starting value is 11.2 moles of A. set up our conversion factor. We're trying to get to moles of C, canceling moles of A. You can see that unit cancellation, moles of A on top, moles of A on bottom. Final answer will be in moles of C. And we'll need the mole-to-mole ratio, so we'll need the coefficients for C and for A. C has a 3 coefficient, A has a 6 coefficient, and we'll simply just be doing 11.2 multiplied by, in parentheses, the 3/6 mole-to-mole ratio. Final answer will be 5.6 moles of C. And this was just a mole to mole conversion.